Okay, good morning to one and all present here.
Good morning, sir.
Okay, so as you know, in last lecture we have discussed our unit number 4. It is our numerical integration. Okay, so we continue with that. So you can see our name of the unit is numerical integration and differentiation. So in last lecture we have completed up to here. You can see here in last lecture we have completed our 4.1, that is Newton-Cotes quadrature formula. Then we discuss about the trapezoidal rule with error, then Simpson 1 by 3, Simpson 3 by 8. So we will start with the Romberg integration in today's session, that is our 4.4. So do you have idea about the trapezoidal rule, everybody? If anyone remember, then please let me know. What is the formula of
Sir,
trapezoidal rule?
trapezoidal rule h by 2 y0
Yes,
plus
yes,
y that yn plus
yes.
2 multiply by all the intermediate values ranging from that y1 to yn minus 1.
Very good, very good. Okay, so that is the very simple rule for integration. And in Simpson 1/3, that is start with the h by 3, and in Simpson 3 by 8, that will be start from 3 by 8. Okay, so in Romberg integration, they focus on the trapezoidal rule, means they take or took the help of the uh, our trapezoidal rule. So you can see here the formula for trapezoidal rule will be this one. Okay, x by 2 y0 plus yn plus 2 y1 y2 y3 up to sun yn minus 1. In the error for that will be minus b minus a divided by 12 x square f square c. Okay, f square c is the maximum value of that f to c, second derivative. Okay, and in the same way you can see the integration formula for Simpson 3 1 by 3 will be the h by 3. Okay, that is the error. So h by 3 y0 plus yn plus 4 y1 y3 up to sun yn minus 1 plus 2 times y2 plus y4 up to sun yn minus 2. And in Simpson 3 by 8, so you see here, then in Simpson 3 by 8 the formula will be 3h by 8 y0 plus yn plus 2 times multiple of 3, that means y3 plus y6 plus y9 and so on, plus 3, then y2 plus y1 plus y2 plus y4 y5 and so on. So this is the formula of a trapezoidal Simpson 1 by 3 and Simpson 3 by 8 rule. Okay, so any have doubt up to here? Any doubt up to here, student?
No, no, sir.
Okay, so we go for the our next method, that is our Romberg integration. Okay, so Romberg integration 4.4 is our nothing but Romberg integration and Gaussian quadrature formula. So Romberg integration, in Romberg integration, this is the theory, but I am not going with the theory, but you can see here. So this is the very important table. So you can see here I of h. So I of h is nothing but your given h. H is equal to, for example, they given 1. Okay, so you start with the h is equal to 1, and I of h will be find out with the trapezoidal rule. Okay, trapezoidal rule. With the help of the trapezoidal rule, you will find out the integration a to b f of x dx. Clear, everybody?
Yes.
Okay, then same way, if you take the h by 2, value of h by 2, then again you will find out the value of a to b f of x dx with the help of trapezoidal rule. Is it?
Yes.
Okay, same way, if you take the h by 4, okay, that is the 1 by 2, 1 by 4, 1 by 8 and continue in this way. means you can say that h upon 1 square, sorry, h upon yes 2 raised to 0, h upon 2 raised to 1, h upon 2 raised to 2, h upon 2 raised to 3, and continue in this way. But in the first column you have to take the help of only trapezoidal rule. You will find out all this value with the help of trapezoidal rule. Is it clear for first column, everybody? Is it clear?
Yes, sir.
Okay. And after that, for the second column, third column, and fourth column, you have to take the help of these two values for the first value. That means you have to take 1 by 3. Suppose this is my I1 integration, this is my I2 integration, this is my I3 integration, and this is my I4 integration. So the formula for this will be 4 times I2 minus I1. That is your first value of the second column. Clear? Understand?
How that 1 by 3, 4 I.
That is the development of the Romberg.
Okay, development by the Romberg.
Development by the Romberg. I already mentioned here, but it is not asked in the examination, so I skip that part. You can see all the things are discussed here. Yes, whatever I am explaining, this is the formula. Okay.
Means as we used to do in that forward difference and backward difference, that we used to take the successive difference. So over here, Romberg has introduced a new method.
New difference between these two integrations.
Yeah, sure.
Okay. Yeah. Same way, if you want to find out this integration, the value of this integration, then this will be nothing but again 1 by 3 4 times. This is your I3, so I3 minus I2. Okay. Then understand? Clear?
Yes, sir.
Okay, now same way, if you want to find out the value of this one, then I3, this will be your 4 times I4 minus I3. Okay, something like this. Okay, done everybody for the second column?
Yes, sir.
Okay, now we go for the next column. That is your third column. So again, suppose I say that this is your first, yes, this is your I5 because we use up to I4, so I5. This is your I6 and this is your I7. So how I will get this value? So same formula will be there, 1 by 3, 4 times I6 minus I5. Okay? Okay, everybody?
Yes,
sir.
Okay. And now, how I will get? Now tell me, you. How I will find out this value of this one?
Will be 1 by 3, 4 I7 minus I6.
Very good. Okay, so continuing this way, you will get your table. Okay, or you will find out the table in the same manner. Okay, suppose this is your this is your I hope this is your I8 and I9. So the same formula will for the fourth column. So 1 by 3 4 times I9 minus I8. Is it everybody understand?
Yes, sir.
So any question, any doubt up to here? Any doubt?
No, sir.
Okay. Now I am going for the example. So you can see here, use the Romberg's method to find integration 0 to 1 dx upon 1 plus x. Correct to 3 decimal places. They given that the correct to 3 decimal place it. So what is my step number 1? So step number 1 will be find out I1, and that I1 with the help of trapezoidal. So again I1 is equal to integration 0 to 1 dx upon 1 plus x, that will be my h by 2 y0 plus yn plus 2 times y1 plus y2 and so on, yn minus 1. Is it, everybody?
Yes, sir.
Clear? Okay, so I go for that one. So I1, here I am taking h. So h is 0 to 1 here. The limit of this integration is 0 to 1. So I am taking h is equal to 2 first. Okay, so h is equal to 2 gives me h is equal to 0.5. Sorry, n is equal to 2. Sorry, n is equal to 2. That gives me h is equal to 0.5. Yes or no?
Sir, how n equal to 2?
Yes, I am taking a plus b divided by 2. Sorry, not that one. Yes, b minus a divided by, yes. So here, how we will get, find out our h in the trapezoidal? Anybody? H.
B minus a upon 2.
B minus a upon n, not 2. Yes or no, everybody? So
Yes.
we will find out h as b minus a divided by n. So if I take the n is equal to 2, then in our case 1 minus 0 divided by 2. So my h will be 0.5. Clear?
Yes, sir.
Okay. So here my h is equal to 2. Now find out the y0, y1, y2 up to sun yn minus 1. Okay, for this value. So you can see here, this is my step number 1. I start with h is equal to 0.5. Okay, so h is equal to 0.5. So 1 upon 1 plus x. So value of 1 upon 1 plus 0. So 1 plus 0 means 1. So this is your first value. Okay. If you remember trapezoidal rule, then it is easy to understand. This is my x0. How I will find out x1? So x1 is nothing but my x0 plus h. So x0 is 0, 0 plus 1, that 0.5. So that gives me 0.5. So this is your x1. Yes or no, everybody?
Yes, sir.
So yes, bolo.
I'm
Yes, tell me.
confused with the three values of h. You have taken 0.5, 0.25, 0.125.
Yes. That is the method of Romberg. I already say that first we take h means n is equal to 2. Okay. Then in second case, if you take n is equal to 4, then h will be 1 minus 0 divided by 4. That will be 0.25.
Yes.
Okay. Now, if I want to take h is equal to 0.125, that means your n will be 8. You can see here. Yes, that will be your 1 minus 0 by 8. What will be your answer?
0.125.
0.125. Everybody, yes or no? This is your h is equal to 0.5. Understand, everybody?
So means we have to go up to what we can say, and we have to increase.
No. The as per the number, this is your first h, then second I of h by 2, then I of h by 4, then h by 8, and so on. That is your first column. If you observe here, you can see h, h by 2, h by 4, h by 8. So in first case, your n is equal to 2. Okay. Okay, in second case, your n is equal to 4. Then?
Yes.
In third case, your n is equal to 8. And so on. Continue.
Yes.
Then?
Yes.
Understand everybody? Yes.
Why are we taking n is equals to 3 in the first case? Or is it just an assumption, or that's how it
You
is always?
you can take n is equal to 3 also, but at that time your h will be changed.
Okay, so the initial value of n we can assign n.
Yes, initial value will be defined as per your given data. If here 0 to 1 is there, okay, 0 to 1. If I break into 3, then that gives me 1 minus 0 by 3. So this will gives you 0.333,
Uh-huh.
yeah, which is more complicated 2.5.
Mm.
That's why we are considering in this way. If you take or go with the 0.3333, then it is okay, no problem.
Okay.
Okay, but basic idea is that your, suppose this is your h. So first you have to split into by 2. That means this will be your h by 2 value. Same if you split into the 4 part, okay, then that is your next integration. If you split into the 8 part, then that will be the next value. Understand?
Yes, sir.
Okay, that is the idea of the Romberg.
Mm.
Understand everybody?
Yes, sir.
Any
Yes.
question? Any question? Anybody? Student, any question?
No, sir.
Okay, so we go for next our table. So you can see everybody here, the first step is find out the value of the integration with the help of trapezoidal rule for h is equal to 0.5. Okay, so you can see here, yes, this is my h is equal to 0.5. Okay, so I go for that. So your x0 will be 0, your x1 will be x0 plus h, so 0.5, and x2 will be x1 plus h, or you can say that x0 plus 2h as per our method of the trapezoidal. So this will be your 0.5 plus 0.5, so 1. Now find out the value of f of x at x0 is equal to 0. So if you see here, then at x0 that will be 1 upon 1 plus 0. So that gives me 1. So your y0 will be 1. Then go for x1. x1 is your 0.5. So 1 upon 1 plus 0.5. So 1 upon 1 0.5, that means 1.5. Okay, so 1 upon 1.5. What is the answer of 1 upon 1.5? Check it. Student, check it.
Zero point 666.
Very good. 0.6667. You can see here. Yes, Ayush?
Yes, sir.
Now you can find out x2. When x2 is equal to 1, then you can find out y2. What will be my y2? So 1 upon 1 plus 1, that is 1 by 2, that is nothing but 0.5. So this is your 0.5. So you have to prepare a table like this. Now, using trapezoidal rule, we have 0 to 1, I of h, that is my I1, you can say I1. So I of h will be 0 to 1, dx upon 1 plus x, that is h by 2. Here I have the values of y only 3. So y0 plus y3 is your first and last value, and 2 times y2 is your middle value. So if you substitute all these values, then we will get this I1, value of I1. Yes or no, everybody? Understand?
Yes, sir.
What about others?
Yes, sir.
सर
Yes,
सर
yes, yes, yes.
इस
बोलो.
गॉस ये मतलब रोमबर्ग इंटीग्रेशन में ये क्या बोलते हैं इसको ट्रोपेजोइडल के अलावा कोई और चीज यूज नहीं हो रही ना
No. Only trapezoidal because it is very simple to do the calculation.
ओके, तो हर एक एग्जांपल में एच चेंज करते जाना है, उसके हिसाब से एन फाइंड करके हमें सॉल्व करना है, ये I1 I2 I3 I4।
Yes. You have to find out I1, I2, I3, I4, I5, I6, and whatever you need. Okay.
ओके ओके
Okay. So
એન્ડ
now,
સર
yes.
ઈ કઈ રીતે ખબર પડશે કે આપણે કેટલા અલગ અલગ એચ ફાઇન્ડ કરવાના?
Wait. Wait. I will explain you. Wait. Okay.
ઓકે
So for next edge is our h is equal to 0.25 as I already discussed here. Okay, 0.25. So I am taking 0.25. So our table will be enhanced. So first value is your x0, second value x0 plus h, that is 0.25, third value x0 plus 2h, that is your 0.5, fourth value is x0 plus 3h, that is your 0.75, and last value is your x0 plus 4h, it is nothing but 1. Our range is 0 to 1, so you have to done your xi with this 0 to 1. Okay, and for that you will find out the our f of x, means this is your y0. Okay, this is your y1, y2, y3, y4. Check this table, everybody. Verify these values with your calculation and tell me if any problem in this table. Understand, everybody? I hope you all understand the first table. So similarly you have to find out the second table. So suppose I want to find this value. Okay, how I will do? So that is your y2. So y2 is equal to 1 upon 1 plus x2. x2 is your 0.5. So again 1 upon 1.5, that is your 0.6667. But if you observe, you have already three values, so don't go with that. Means first one 0.667, that is already there, and 0.5 is your last value. So you have to calculate only these two values. Tell me these are correct or not. Check, everybody.
Sir, those are correct, but the final answer of I2 is getting 677025. 677025.
Check again with the h is equal to 0.25. Check it.
Yes, sir, I have checked twice.
Yes. What is the answer?
0.677025.
7725. Anybody else who get this answer? Please verify this, everybody.
Sir, 697025. It is correct, I guess.
It is correct. Yes. Okay. So that's why
697025.
Okay, 70. We need only 4 digits here. Okay, not a problem.
Okay, sir.
Okay. Now I hope you all get this table and this value. Everybody, yes or no? Tell me.
Yes, sir.
Yes, sir.
Okay, now if you consider h is equal to 0.125, how we get it? Divide by 8. Taking n is equal to 8, you will get the 0.125. So here your table will be enhanced. You can see you have the 5 values as it is. First one, third one, fifth one, and 7th and last one. Okay, and now you have to calculate other values here and find out your f of x.
Sir,
Yes.
okay. If we are comparing table 1
Yes.
and table 2,
Yes.
you can see that n in table 1 is equal to 2, right? And then n in
Yes.
table 2 is
4.
but now n in table 1 is giving us up to y is equal to giving us up to yn is equal to
y8.
y2.
Yes, y8 is there. So you can see y0, y1, y2, y3, y4, y5, y6, y7 and y8. Why this happened? Because we are considering n is equal to 8 in our example.
Upper in table 1.
Yes, in table 1 n is equal to 2.
N is equals to 2.
Yes, in second table n is equal to 4.
And why is it that in table 1, in the final answer finding IH, you have
Yes,
taken
I.
Y3?
Yes, I. These all gives us I in value of integration. That's why I am writing down here I.
But why have you taken I is equal to H by 2 in bracket Y0 plus Y3? Y3 there.
Y0 plus Y3 because here our table is up to Y3. Y0, Y1 and sorry, Y2. Okay. There is a mistake here. Yes. Thank you. Y0, Y2 and this will be your Y1. Yes. Thank you. Okay, there is a typological error. Okay. Yes. Thank you. And anybody have any problem up to here? Are you doing or not? How I can see? Student.
हाँ सर कर रहा है पर कोई दिक्कत नहीं है.
Okay, no problem. What about others? Ayushman, Krishna.
सर हो रहा है.
Yes, sir. Doing, sir.
Okay.
Just on the way.
Okay, so we can say this is your I2. Okay, now this is your I3. So you can see here, if I go for n is equal to 16, then my table will be more complicated. Yes or no? Everybody?
Yes.
Okay, so we have to done for first three values I1, I2 and I3 and check whether we will get our answer or not. And if you not getting that answer, then you have to enhance or you have to go for more calculation. Otherwise you have to done with I1, I2 and I3. Okay. Okay, Saumil. Justin.
Yes sir.
Yes.
So I hope you will get all I3 value of I3 also. Saumil, is it correct? I hope this is not correct.
Yes sir.
No, not correct. This is 0.6941 if I am not wrong. Check it again.
સર
Yes.
સર એમાં છે ને 0.8 એડ નથી કરેલું એ લોકોએ.
Yes. That's why I am saying that this is 0.6941. So your first 1.5 is correct. So in second, 2 times 0.89, 0.7. Forgot to write here plus 0.6941. Yes. Okay, everybody, keep in your mind this is a typological error here. So don't go with the same value. Okay, this is your 0.6941. Answer is 0.6941. Correct? Okay. Yes.
સર આપણે જ્યાં સુધી ટેબલ આપણું બહુ લેન્ધી ન થઈ જાય ત્યાં સુધી ફાઇન્ડ કરવાના ને આઈ.
Yes. Not up to that, but we have to mention here up to 3 decimal. So we have to concentrate on 3 decimal. Okay, if we will not get, then go for the more calculation.
Means
તો
then
આપણે
we
એક્ઝેક્ટ પ્રોપર મેથડ કઈ થાય કે જેના થ્રુ આપણે ફાઇન્ડ કરી શકીએ કે આટલા જાય આપણે ફાઇન્ડ કરવાના?
No, we cannot say like that.
ઓકે, એટલે ડેસિમલ અને જે પ્રમાણે ટેબલની લેન્થ.
Yes. We more focus on the decimal. Okay, and for our simplicity we go with the table.
ઓકે એન્ડ સર એવું જ થશે ને કે જેટલા વધારે આઈ ફાઇન્ડ કરશો એટલા પ્રિસાઇઝ આન્સર મળશે.
Yes, very good. Yes, it is correct. Okay, if you
Okay.
go with more and more values, then your answer will be more precise.
So, sir, can we conclude that let's say 3 decimal places are say so going for h up to 0.5 means up to 3 values of h is okay?
If you observe here, these two values nearer, you can see 0.6970, 0.6941. So up to 2 digit both are same. So we can
Yes.
say that we have to stop here. Okay. If the value will be not matched up to 2 decimal, then we have to go for more calculation.
Okay,
Understand?
okay, okay,
Clear?
okay.
એન્ડ
Okay.
સર આપણે
Yes.
n equals 3 કે n equals 5 એ લઈ શકતા હતા ને?
If you take that, then your table will be more complicated.
n equals 3 માં કોમ્પ્લિકેટેડ થશે?
Yes, you can check.
હા બરોબર.
Then, okay.
યસ.
Okay, if your partition are even, then you will be more good answer, or your calculation will be reduced. Okay, because you can see here, if I split 0 to 1 into 2 part, then that is 0 to 0.5, 0.5 to 1. Okay, it is easy to understand. But if you split into 3 part, then 0 to 0.3, 0.6, 0.9, and then you will not get 1 exact. So that's why we go for the even numbers of n. Okay.
યસ સર.
Okay. Now, as per our table, you can see our first value of I1 is 0.7084. Second value of I2 is 0.6970. And third value, that is my I3, it is 0.6941. Now, I want to calculate my I4 and I5. So, the formula for that will be 1 by 3, 4 times I2 minus I1. Check this value. By substituting 1 by 3, 4 multiplied by 0.6970 minus 0.7084. Check it.
સર
Yes.
સર i3 ની વેલ્યુ 0.756625 આવે છે.
No, it is wrong. Man. I hope this is correct value. Please check Man. Once again.
ઓકે સર.
0.6932.
Yes, yes. 0.6932 is your I4. Okay, everybody got it? This value, I4? Student, I hope you get this.
Yes, sir.
Okay. Now, similarly, if we get I5, if I want to find I5, then same formula will be there. 1 by 3, 4 times I3. I3 is my next value. So, 0.6941 minus point I1. I1 is not there. I2 is there. I2. So, 0.6970. Tell me what we will get.
0.6931.
Yes, 0.6931. Okay, so this is my I5. Now this is my second column. Now I go for the next column. So here I reached up to I5. So I6 will be same way. I6 is equal to 1 by 3, 4 times I5. I5 is your 0.6931. So 0.6931 minus this is your 0.6932. Now find out this value.
0.6930.
Yes, 0.6930. 6930.
6930.
Yes. Everybody got this value? Everybody?
Yes, 0.6930.
Yes. Okay. So if you observe here, we have the values with the 3 decimal, correct up to 3 decimal. So you can see. Done? Okay. So we have to stop here. Done? Understand everybody? Are you there?
Yes, sir.
Okay.
Yes,
So
sir.
Yes, sir.
yes. So the final answer will be, so the required value of integration 0 to 1, 1 upon 1 plus x is, what is your final answer? 0.6930. And if you see the fifth digit, there will be rounding, with the rounding 1. We will get 1. What is the answer here? 0.6930.
6666.
Yes, 666. So I can add here 1. 0 will be 1. So 0.6931. If I am not wrong. Clear? So your answer will be 0.6931. Clear? Understand everybody?
Yes, sir.
So this method is known as the Romberg integration, and it gives you precise answer for the integration. Okay, more precise than trapezoidal Simpson and Simpson 3 by 8. Okay, because there is a more calculation in this method, so it gives you more precise answer as compared to the trapezoidal rule, Simpson 1 by 3 rule, and Simpson 3 by 8 rule. So any question, any doubt in this example and in this method? Anybody?
No, sir.
Okay, so you can try second example here. Yes, this is the wrong. Yes, now you can try with this one, 0 to 1 dx upon 1 plus x square. I will help you. Okay, now we start with this one. Okay, I prepare one blank file for you, so we can do that. Okay, now everybody visible this blank file?
Yes, sir.
Okay,
Yes, sir.
so we go for the second example. So you will aware more about this method, 0 to 1 dx upon 1 plus x square. So okay, so my integration is 0 to 1 dx upon 1 plus x square. Okay, so I want to apply the Lemberg method to this integration. So again I start with the I1. I1 is your my I of h. I of h, that means I am first considering h is equal to 0.5. Okay, clear? So 0.5, so 0.5 divided by 2, integration of y0, here y0, then y I think 2 is that, and 2 times y1. Okay, so now find out our y0. So y0 will be 1 upon 1 plus 0, it gives me 1. y1 will be 1 upon 1 plus 0.5 whole square. Now tell me what is the answer of this one?
0.8.
0.8, and y2 will be your 1 upon 1 plus 1 square, so 1 by 2, that will be 0.5. Yes or no, everybody? Okay, done up to here? Clear or not? Clear, everybody, or not?
Yes,
Yes.
sir. Clear.
Okay, so this will be your 0.5 divided by 2. Y0 is your 1 plus 0.5 plus 2 times y1. Y1 is your 0.8. Now tell me what is the answer of this first integration? I1. Tell me what is the answer?
0.775.
Yes, 0.7750, I think, because we need up to 4 decimal. Okay. Is it done?
Sir,
Okay. Now second edge. Second edge is your my 0.225, or what is our
excuse me,
value?
sir.
Yes, yes.
Sir, Yogeshwari ma'am was telling that if we are in any sum, we are asked up to going up to, let's say, n decimal places, so we have to write in the answer means what when we are calculating. So during the procedure of the calculation, we have to go more than n. Let's say we have to write 0.77500, or let's say any digit come, so it will
I
be
mean,
more.
yes. If you write down here fifth digit, then you will get the more perfect answer. Not a problem, Krishna.
Okay, sir. Means either it's okay with 4 also.
4 also means if you taking here rounding number, then it is perfect, not an issue.
Okay, sir.
Okay, if you go means when you increase your decimal, then your error will be minimized, Krishna.
Yes.
Okay, huh? So you can go with that also, not issue. You can go with the 5 digit here also, so that then your error will be less. Okay.
Yes.
Now tell me what is my second value of h? Anybody? 0.25. Yes, 0.25. So this is your value of x, fx. So find out a table. So this will be a 0, then 0.25, then 0.5, then 0.75, and last value is 1. So I have 3 values. So 1, 0.8, and 0.5. Okay, now find out 2 other values for 0.25. How we will get? So y1 is equal to, for that y1 is equal to 1 upon 1 plus 0.25 whole square. So what should be your value? Do fast, huh, everybody?
Point 0.8. Sorry, sir.
No, not it is 0.8. 0.25 whole square. Ayush. Somil, are you there?
Sir, 0.
Yes, sir. I'm calculating the whole sum. After then, I will start answering.
Okay. Yes, Ayush. What do you get? Point?
0.8858.
No. It is not correct.
0.941.
Very good. 9412. Okay.
Yes.
0.9412. Now your y2 y3 will be your 1 upon 1 plus 0.75 whole square. I will check again.
Yes, sir. आ गया.
Okay. And Man, did you get this I6 or not?
Yes, sir. I give.
Okay then. Yes. What is your y3?
0.64.
0.6400. Yes.
Yes.
Okay, 0.6400. So your second I2 will be your I of h by 2. We can say this will be your h by 2. That gives 0.25 divided by 2 y0. That sorry, y0 plus y1 0 1 2 3 4. So 4 plus 2 times y1 plus y2 plus y3 by using the trapezoidal rule. So we get 0.25 divided by 2 and y0 is 1 plus 0.5 plus 2 times y1 is your 0.9412 plus zero point 0.8 plus 0.6400. Okay, now tell me what is the answer?
0.7828.
Yes. हाँ? So आधी तो डायरेक्ट जवाब है. Yes, what we get? Point
7828.
7828. Correct answer. Okay. So up to here, any problem? Anybody?
No, sir.
Now next my h. What is my next h? What should be my next h? H is equal to 0.125.
125.
Yes, 125. So x, f of x, then find out 0, then 0.125, then 0.25, then 0.25, then what do we get? Point next 375, then 0.5, then 0.625, then next value is 0.75, then 0.875, and last value is 1. Okay, so calculate all these values. So 0 we have 1, 0.25 we have 0.9412, then 0.5, 0.8, then 0.6400. This will be your 0.5. Now you have to calculate 4 more values.
Sir, bolu.
Yes.
0.9846,
0.9846,
0.8767,
0.8767,
0.7191,
point
7191,
91,
0.5663.
0.5663.
Hmm.
Check everybody, please check these values, new values, 0.125, 0.375, 0.625, and 0.875. How we will get those who join right now? You can see I want to find this value. So our function is 1 upon 1 plus x square. So your this value will be calculated as 1 upon 1 plus 0.125 whole square. Okay. So that gives you 0.9846, but you have to verify. Is it correct? Everybody? Ayush, Krishna, Mohan, and Jinal. Those
Yes,
who are
sir.
Yes, sir. Yes, sir.
okay.
Yes, sir.
Okay. So this table is now complete. Now I want to find my
Sir,
I3. Yes, yes.
sir, but that 0.625 0.7191 I am getting.
0.62191. I write down here 91.
Okay, okay.
Okay.
Yes,
Okay.
because it was just looking for one, so I confused just.
Okay. Okay. No problem. Then I3, that will be I of h by 4. Okay, so this gives me h by 3, then sorry, h by 2, then y0 plus 1 2 3 4 5 6 7 8, y8 plus 2 times, now we have the y1 plus y2 plus y3 plus y4 plus y5 plus y6 plus y7. Now solve, substitute all these value here. So my h is 0.125 divided by 2, y0 is your 1, y8 is your 0.5, first and last value, then 2 times addition of these middle values. So 0.9846 plus 0.9412 plus 0.8767 plus 0.8 plus 0.7191 plus 0.6400 plus 0.5663. Okay, done. Now calculate this, everybody.
0.7847.
0. I am writing here
7847.
0.7847. Is it 7847? Everybody got it?
Yes, sir. Yeah.
Okay. And after rounding the fifth digit, what we get here?
Sir, round off કરીને જ કીધું છે.
Okay, okay, done. Then it is correct. No problem. Done, everybody? Now we have to check with our
Sir,
values.
1 minute, just 2 minutes. I am just calculating.
Okay, no problem. Our first value is 0.775, second value is 0.7828, and this will be changed at 0.7847. Yes, Somil?
7047, sir. 7847. 7847.
Yes, 7847. Okay, so we will get all
Yes.
these values. Okay.
0.78473.
Okay, no problem. Okay, done. So I start with my table. So this is your I1, I2, and I3. So my I1, what is the value of I1?
0.775.
7750. So 0.7750. Second value 0.7828,
0.7828.
and third value 0.7847. Okay, now I am going for the I4. I4 is 1 by 3, 4 times I2. I2 is your 0.7828 minus I1, that means 7750. Now tell me what we will get here.
0.7854.
7854. Very good. Then I5. I5 will be calculated by 1 by 3, 4 times I3, that means 0.7847 minus this will be your 0.7828. So we will find out as
0.7853.
53. Is it, everybody? Do you got it? Everybody?
Yes, sir.
Okay. Now I6. How I will find out I6? So that will be 1 by 3, 4 times I5. I5 is 0.7853 minus I4, that is 0.7854. Now
0.7853.
yes, 0.7853. Okay, so now you can see here, if you observe, then our answer is here. So this will be your same values. Okay, I5 and I6 both are same up to 4 decimal. So we have to stop here as per our statement, because you can read here, use Romberg method to find 0 to 1 dx upon 1 plus x square, correct to 4 decimal places. Is it okay, everybody?
Sir, in the previous one also that I5 and I6 were equal, that 0.6931 up to
Yes,
that.
yes,
Similar.
up to that we have to stop it. Yes, not a problem.
If okay, that I5 and I6 are not equal, but I4 and I6 are equal, then also we have to stop.
Yes, we can stop there, no problem. But as per our difference table, you can see where we reach up to the single value. Okay, our table will be up to single values. That's why we are going in that direction.
Okay, so the preceding column, any value, if the value matches just one value, then we have to stop.
We have to stop. Yes, we have to stop it. Okay.
Okay, sir.
And this is this table is only for simplicity. If you go in this way also, then it is not a problem. Okay, we have to write in the table for the simplicity, just only for the simplicity. Otherwise, if you do this exercise in the similar way, then it is not a problem. But you have to check the preceding values will be same. Okay.
સર આપણે I1 I2 અને I3 ફાઇન્ડ કરી છે, એના માટે ઓલા જે ટેબલ હર વખતે લખી છે લાંબા લાંબા, એ ન લખી તો ચાલે?
No, you have to mention it. Samil.
Okay.
Okay. Done. So I hope you all are getting the idea of the Romberg method. So any question, any doubt in this method? Anybody? Student, any doubt, any question in the Romberg integration method?
No, sir.
Okay. Okay. Now we go for what about others? Only Ayush will reply. Sorry, Ayush is replying. What about other? Yes, yes. Many people are thumbing. Wow. Thank you. Okay. Now we go for the next method, that is your Gaussian quadrature formula. So Gaussian quadrature formula, you can see here, Gaussian quadrature formula gives us the answer of the integration same way. So there are, you can see 5 methods in your syllabus to solve the integration. So first is no, sorry, 6 method. First formula is the, you can see here, there are 6 methods to find out the or to solve the integration. Yes, first is the Newton-Cotes quadrature formula. That is the general formula you can see here. Then second formula is your trapezoidal rule. Third formula is your Simpson one-third rule. Fourth formula is your Simpson 3/8. Now in today's lecture we started with the Romberg integration, and the last formula for the find out the integration, that is the Gaussian quadrature, which is direct formula. In 4.5 we will use our previous formulas, which is known as the Newton's forward and Newton's backward. So I am not considering that in the our formulas case, because we already learned that. So new formula for find out the integration is 5 in this unit. Okay, everybody?
Yes,
Yes,
sir.
sir.
Okay, so we go for the that formula, and in that formula you have to, yes. So what is the idea of the Gaussian curvature? So the idea of the Gaussian curvature is this formula. What is it says? So integration must be between -1 to 1. Then you can apply the Gaussian quadrature formula. Clear, everybody? First criteria. Integration must be in the form of -1 to 1 f of x dx. Clear?
Yes.
Okay, so Gaussian find out this integration with the help of the weight function, weights, wi, weights. So you can say first is your w1 f of x1, second one is your w2 f of x2, and so on. Last value of wn f of xn. Clear? So this is the general formula for the Gaussian quadrature. But we, in our syllabus, there are only 3 formulas, which is the 1-point Gaussian curvature formula, 2-point Gaussian curvature formula, and 3-point Gaussian curvature formula. Okay, so in first, if in 1-point Gaussian curvature, there is only one term will be there. In the 2-point Gaussian curvature, there are 2 terms in this general formula. In the 3-point Gaussian curvature, they go up to the 3 steps in the general formula. Okay, everybody understand?
Yes, sir.
Okay, so a 1-point Gaussian curvature formula will be -1 to 1 f of x dx is equal to 2 times value of the function at 0, f of 0. So they find out w is equal to 2 and x1 is equal to 0. And substitute that in the general formula, you will get this first formula, 1-point Gaussian quadrature formula. Okay, done?
Yes.
Okay, in 2-point Gaussian curvature, there are 2 terms. So your W1 will be 1, W2 is also 1, your X1 is -1 by root 3, and X2 is 1 by root 3. So -1 to 1 f of x dx is equal to f of -1 by root 3 plus f of 1 by root 3 is your 2-point Gaussian quadrature formula. Okay. Done, everybody? Understand?
Yes, sir.
Okay. And 3-point Gaussian quadrature formula. There are 3 terms. So they started with the W1 is equal to 5 by 9. X1 is your minus root 3 by 5. W2 is 8 by 9. X2 is your 0. Then W3 is your 5 by 9. And X3 is your root 3 by 5. Okay, f of root 3 by 5. So this is your 3-point Gaussian quadrature formula. Okay, they use simply the polynomial way to derive this all this W1 X1, but it is not in your syllabus, so we are not go into the deeply. But you can, if you are interested, then we can discuss whenever you are free. Okay, you can contact me anytime. Okay, student, how they get this X, W1, W2 and all these things, we can discuss when you are free. Okay, so there are 3 more formulas in this method. 1-point Gaussian quadrature formula, 2-point Gaussian quadrature formula, 3-point Gaussian quadrature formula. So you have to write down all these formulas. So any question in these formulas? Anybody? Student, any doubt? Any question? Okay. So the main criteria to apply the Gaussian quadrature formula is your limit must be between -1 to 1. If your limit is not in the proper form, then you have to convert your integration in the proper form and then apply our formulas. Okay, everybody? Done?
Yes, sir.
Okay, so now I go for the first example. So you can see.
Sir,
Yes,
sir, can you
yes.
just only 1 minute, just only
Okay,
1 minute.
okay.
You're right.
Okay.
Sir, in the 3.1, that f by 9 f multiply by minus under root 3 by 5. Yes, that is what.
5 by 9. 5 by 9 into f of minus root 3
Oh,
by 5. That is the coefficient, W1, Krishna.
yes, coefficient.
Yes, coefficient of this function. Okay.
Okay, sir. Yes.
Done? Now,
Yes, sir.
can we proceed? Yes. Okay.
Yes, please.
So, yes. Now, next example. Evaluate -1 to 1 dx upon 1 plus x square by 1 point, 2 point and 3-point Gaussian formula. So, as we know, our integration is in the first -1 to 1. Okay. So, we can apply directly the Gaussian formula. So first 1 point, so you can see here -1 to 1 f of x dx, that means 2 f of 0, that is the formula. How we will get this f of 0? So f of 0 with the help of your function f of x is equal to 1 upon 1 plus x square. So substitute x is equal to 0 in this form. So 1 upon 1 plus 0, that gives you 1 by 1. So 1, so 2 into 1 will be 2. So your first value we will find it. Okay, done. 1 point Gaussian quadrature formula. This method is very easy. If you have the formula, then you have to substitute only, not a major rule or not a complicated form of this method. Understand? 1 point, everybody? Okay, it is very easy. Now in 2 point, if you want to find out the 2 point Gaussian quadrature formula, then you have to find only two things. Which are they? F of minus 1 by root 3 and f of 1 by root 3. So you can see here for 2 point Gaussian quadrature formula, I am zooming it. Yes. Okay. So minus 1 to 1 f of x ds is, this is our formula, f of minus 1 by root 3 plus f of 1 by root 3. So if I find out f of 1 by minus 1 by root 3, so how we will calculate it? So 1 upon 1 plus 1 by root 3 whole square. So 1 upon 1 plus 1 by 3. So find out this. So this will be give you 3 by 4. Yes or no? If you're taking the LCM, then 3 plus 1, 4, and 3 is the upper side, so 3 by 4. Okay, same way, f of 1 by root 3, it is say again same value 1 by root 3 because there is a square in our function, so it will not change, so 3 by 4. So 3 by 4 plus 3 by 4, it gives you 3 by 2. Correct? Everybody understand? Student?
Yes, sir. Understood.
Okay.
Yes, sir.
Okay, now same way 3 point Gaussian quadrature formula. You can see this is our formula. So now you have to find out f of minus root 3 by 5 first, then f of 0 and f of root 3 by 5. But we already find out f of 0 in the 1 point. So you have to replace simply the answer of that one. Now f of minus root 3 by 5. So it will find out in this way 1 upon 1 plus minus root 3 by 5 whole square. So this gives you 1 upon 1 plus 3 by 5. So we will have 5 by 8. Okay. Yes, 5 by 8. So again the same answer for the f of root 3 by 5 because there is a square in our function, so it will not change, so 5 by 8. So now replace here, so 5 by 9 is the coefficient, then 5 by 8 is your answer of f of minus root 3 by 5, then 8 by 9 into 1 is the answer of f of 0, then 5 by 9 into the answer of f of root 3 by 5 is 5 by 8. Now multiply and add these three terms, you will get the 1.5833. Okay, everybody? Done? Do you get this answer? Student?
Sir, calculating.
Okay. If you complete, then please inform me. What about others? Are you doing or not?
Yes, sir.
Okay,
Yes, sir, doing.
okay. Yes, and D2D student, please make sure this method is very simple for you. So please do and prepare for the examination. This method, all 1 point, 2 point, and 3 point is very easy to find it.
Yes, sir. It is getting correct.
Yeah. Okay. So 1.5833 is correct answer. Okay. There is no typological error here. So any question, any doubt in this method or this in this example? Anybody? Okay. Now I go for the second example, but not go in the solution for that. First I have to explain something. Yes. Okay. I hope all students done first example. Give me your confirmation, please, everybody.
Done, sir.
Yes, done.
Done.
Yes.
Okay. Thank you. Okay. Now we go for the second example, which is very important for you. So evaluate integration 0 to 1 dt upon 1 plus t by 1 point, 2 point, and 3 point Gaussian formulas. Okay. So if you observe here, your range of integration is not in your proper form. Yes or no, everybody? For this method. So
Yes, sir.
because it is not in the form of -1 to 1 for Gaussian formula. So we have to convert this into the Gaussian form, and then we have to calculate our 1 point, 2 point, and 3 point Gaussian formula. Okay. So how we can transfer? Anybody?
Divide by 2.
Divide by 2 simply. Check it. What you get it? So
We have to find the corresponding formula in such a way that will again fulfill the same integration.
yes,
The answer
yes.
complements it in that way.
Yes, you have two options. Okay, you have two options here. First option is t is equal to, you consider any t directly by error, by thinking what we can consider in terms of t. Okay, tell me. I am considering 1 by 2 t, or sorry, x plus 1. Is it correct? Can we take in this way? Now check your limit. When t is equal to 0, what will get x, value of x?
-1.
-1. Very good. Okay. And when t is equal to 1, what we get x?
1.
1. That means my supposition is correct. Yes or no, everybody?
Yes.
Okay. But how we can get this? How? So there is a simple formula for that. So keep in your mind, b minus a by 2 into x plus b plus a by 2. So in this way, you can also find the same value of t. You can check. Both are same here. Correct? Substitute your a and b here. So if you substitute here, then we get 1 minus 0 by 2 into x plus 1 plus 0 by 2. So that gives you 1 by 2x plus 1 by 2. So if I take outside, then this will be x plus 1. Okay, so there are two ways. If you go with this formula, then we will also get the substitution part. And you can try with your try and error method. You will also get your t. Clear, everybody?
So instead of that t, now we have to put that half t plus 1.
Yes, how? Okay, so let me explain our example. Now, is it clear? These two ways, everybody? Is it correct? Everybody, or understand,
Yes, sir.
everybody? Yes. Okay, so now I start with that example. So here, consider, okay, we can start in this way. Here, consider t is equal to 1 by 2 x plus 1. Okay, that gives you, that implies dt is equal to dx by 2. Okay, so I got this one. And when t is equal to 0, then x is equal to -1, and t is equal to 1, that gives me x is equal to 1. So this is my first part of this example. Okay, so our given integration, our integration transforms to integration 0 to 1 dt upon 1 plus t. That gives me minus 1 to 1, 1 upon 1 plus t. T is replaced by 1 by 2 x plus 1 into dt. dt is your dx by 2. Now, done some exercise here. So, if you see here, then that will be minus 1 to 1. Dx is upper side, then divide by, what we get here? 2 plus x plus 1. Okay, if I take the LCM here divide by 2. Yes or no, everybody? And there is also divide by 2 in upper side. Is it correct? Student, are you getting my point?
Yes.
Okay, I am substituting only value of t and the limit of nu over x. Okay, so this will be your minus 1 to 1 dx by x plus 3. So this will be your new integration. Now you have to apply our Gaussian quadrature formula on this integration, because our 0 to 1 dt by 1 plus t is tends to minus 1 to 1 dx by x plus 3. Now
સર
understand? Yes.
આપણે જે રીતે ઓલું કરતા કે માઇનસ એ થી એ ને આપણે 0 થી 1 0 ટુ એમાં કન્વર્ટ કરવા માટે મલ્ટીપ્લાય બાય 2 કરતા, તો આને સિમ્પલી ડિવાઇડ બાય 2 નો કરી શકીએ ઊંધા કન્વર્ઝેશન માટે?
No.
કે 1 by 2 integration minus 1 થી 1 dt by 1 plus t.
No. Tell me again. Please.
આપણે એવું લખીએ છીએ ને કે 0 to a minus a to a
minus a to a.
હા, પછી 1 plus એટલે કોઈ પણ ફંક્શન છે minus a to a f of x.
Okay, f of x dx. This will be 2 times this one. You say that.
Yes, હા એમ કહું છું.
2 times.
હા, તો આપણે આમાં એવું ન કરી શકીએ સિમ્પલી કે divide by 2?
Saumil, how, when this will happen? When function is even. Saumil, if the function is not even, then you cannot go with this one.
Okay, ભૂલી ગયો તો.
Okay, everybody understand what Saumil says? Saumil says that we have the one more concepts regarding this, minus a to a f of x dx. Then you can transfer into 2 times integration 0 to a f of x dx. It is correct. But when this will happen? Only when your function is even. Okay, if your function is odd, then this will be tends to 0. Okay,
0.
Yes. Okay, so keep in your mind, you cannot directly go with this one. If your function is even, then you go with this one, not a problem. But if your function is not even, then don't go with this one. Okay, everybody understand? Tell me your confirmation, please, student.
Yes, sir. Confirm.
Yes, sir.
Okay. Now I want to find the 1 point. Okay, so first 1 point Gaussian quadrature, that means GQ. I am writing down GQ. Don't write down GQ in your examination. So that will be minus 1 to 1 dx upon x plus 3. That equal to, what is the formula? 2 times f of 0. So 2 times 1 upon 1 plus 0, that will be your 2. Sorry, 1, no, 1 plus 0, not 1 plus 3. Okay, sorry, 0 plus 3, not 1 plus 3, 0 plus 3. So this will be 2 by 3, and the answer of 2 by 3 will be 0.2. 6667? Yes or no? Check it.
Yes.
Okay. Now second, 2 point Gaussian quadrature, that will be -1 to 1 dx upon x plus 3, that will be f of -1 by root 3 plus f of 1 by root 3. So that will be 1 upon x is your -1 by root 3. So -1 by root 3 plus 3 plus 1 upon 1 by root 3 plus 1 plus 3. Sorry. Yes. Now tell me what is the answer of this one?
Excuse me, sir.
Yes. Yes.
Sir, up to how many decimal places we have to go? It is mentioned in question quadrature.
No. No. It is not needed in Gaussian quadrature. Okay.
So we take by default 4.
4. Yes.
Okay. Yes.
Okay. And there is no number of iteration in this method, Krishna. So they don't need that part.
Yes, sir.
Okay. They directly find out only 1 point, 2 point, and 3 point. Nothing else. Tell me what is the answer of this?
9 by 13.
9 by 13.
0.6923.
Yes, 9 by 13. But what is the answer in the fraction form?
0.6923.
0.6923. Okay. Justin, is it correct?
Yes,
It
sir.
matched with your answer?
Yes.
Okay.
0.6923.
Yes, good. Then 3-point Gaussian quadrature, 3-point Gaussian quadrature, we have -1 to 1 dx upon x plus 3, that will be your 5 by 9, f of minus root 3 by 5 plus 8 by 9, f of 0 plus 5 by 9, f of root 3 by 5. Okay, now you can find this. So 5 by 9 into 1 by minus root 3 by 5 plus 3 plus 8 by 9 into 1 by 0 plus 3 plus 5 by 9, 1 by root 3 by 5 plus 3. Okay, now tell me the answer of this one.
Sir, I am getting 0.7683.
No, please check again. Find out separately. Okay, if you find out in 3 different terms, then your perfection will be there.
Sir,
Because
0.98945.
no, it is similar to 6.9. Okay, not more than it. Because if you observe first two values, then it is 6667.69. So 0.6 will be there. Okay. there is no far away from 0.6. Okay, 0.6 is already there. After second, third, fourth digit, you can change. So your answer must be in the form of 0.6. 0.6, check it.
Point 67167.
67, I think it will be 0.6931, Justin. It might be wrong, but you have to verify.
Okay.
Okay.
Sir, I am getting 0.6718.
No. No. This is the perfect answer. So you have to check again, everybody. Okay, I verify this one. And keep in your mind, this is the whole square root of 3 by 5, not only root 3 by 5. Okay, keep in your mind, this will be whole.
Sir,
Yes.
the answer 0.6889 આવે છે.
0.6889. Any other answer? Yes, Saumil, what is your answer?
Till now I am getting rough થઈ ગયો, sir.
Okay. Okay, no problem. Anyone have any other answer?
I am calculating it again,
Sir.
sir.
Yes.
0.6931.
Yes, very good, Justin. Yes, your answer is correct, Justin. So, Man, the correct answer is 0.6931.
Okay, sir.
Okay. So this is the method of Gaussian quadrature. So anyone have any question?
Sir, 0.6930 चलेगा?
30 is correct, not a problem. 30.
Okay, आ गया.
Okay, done. So any question, any doubt in this method and in both the example? Anybody? You can see whole example is calculated here. Okay, all steps are there. So you go through it. Okay, all the example, all the steps are given here. I write down it again in front of you. So any question, any doubt in this method, Gaussian quadrature?
No, sir.
What about others? Please give me your confirmation.
No, sir.
Okay. Yes. Okay. Now, last method of this unit. It is very easy for you, and that is the yes. So last method of this unit, that is the numerical differentiation. So these 1 to 4 for the integration.
Sir.
Yes.
ये जो हमने ये गॉसियन क्वाड्रेशन फॉर्मूला किया, उसमें हमेशा थोड़ी हमें लिमिट -1 to 1 या फिर 0 से 1 के लिए दी होगी, कोई अलग दी होगी तो हमें क्या करना है? वही सेम जो फॉर्मूला है उसी में डालना है ना सर?
हाँ, उसी से मिल जाएगी आपके. मोस्ट ऑफ द प्रॉब्लम्स विल बी सॉल्व विद दैट फॉर्मूला.
ओके.
Okay, so 4.1, 4.2, 4.3, and 4.4 for the integration. Now we go for the second part of our unit, that is the differentiation. So in this topic, we have the idea about the dy by dx, d square y by dx square. Okay, but in that we have to use the direct formula. Okay, so in this topic we will go with the difference formula for the dy by dx at x is equal to x0, d square y by dx square at x is equal to x0. Okay, so in this topic we go for the forward difference and backward difference table. Okay, and from that we will calculate our differentiation value of the differentiation at that point. Clear, everybody? What we are going to find it? Understand?
Yes, sir.
Okay, so simply you can say that, yes, I am writing here. Okay, so simply we can say that we have the idea about the dy by dx and d square y by dx square and so on, d cube y by dx cube and so on, continue in this way. But we have the idea with the formula, directly formula. But if suppose I want to find dy by dx at x is equal to 0 with the help of the forward difference or backward difference, then how we will calculate it? That is the topic which is 4.5. Clear? Understand, everybody?
Yes.
Okay, now we start with the first our forward difference. So what is the formula of Newton forward interpolation? What is the formula of Newton forward interpolation? Anybody?
y0 plus
y0 plus r
r delta y0
delta
delta
y0. Yes, very good. Then
and
r
r minus 1 divided
divide,
by 2 factorial
yes,
delta
del,
square y0 plus
yes,
r minus 1 multiplied by r minus 2 divided by 3 factorial delta
very
cube
good,
y0
very
and
good, very good.
dot
And
that
so on. Yes, and so on. Is it? Yes, everybody?
yes.
Okay.
Yes.
Okay. Now we go for our derivative. So what do you mean by derivative? So dy by dx. So can we write down this dy by dx as dy by dr into dr by dx? Chain
Yes.
rule? Okay.
Chain rule.
Okay. Yes. Okay. So this is the simply idea of this method. Okay. Very simply idea. Now you have the formula for R also. What is the formula of R in the Newton forward? So x minus x0 divided by h.
Yes.
Okay. So now tell me what is the value of dr by dx from this formula? From this formula, what is the derivative of r with respect to x?
uh, it will be
Minus x
1
not by
minus
h.
No,
1
1 by
minus
h, 1 by h, 1 by h, because x0 is the fixed value.
yes, yes,
Okay,
Okay.
okay, so x is 1, the derivative of x is 1, so 1 upon x, that is your dr by dx. And okay, now tell me what is your dy by dr from this formula number 1. So dy by dr. What is the for dy by dr from this formula? So the derivative of y0 is 0. Yes or no?
Yes.
Uh, uh, Derivative of r with respect to r is 1. So here we have the delta y0. Is it?
yes,
So 1 by 2 factor is already there. Now simplify this. So this will be your r square minus r. Yes or no?
Yes.
So now differentiate this. We get 2r minus 1 into delta square y0. Is it?
Yes.
So can we continue in this way? Dot dot.
What we have to do for that third one, r minus 1, r minus 2 divided by 3?
You can do not a major issue, r square minus r into r minus 2. Now again multiply that will be r cube, okay, minus 2r square minus r square minus minus plus 2r. So this term will be your r cube minus 3r square plus 2r. Now differentiate it. So we will get here 3r square minus 6r plus 2 divided by 3 factorial into delta q by 0. Krishna, done?
Yes.
Okay, now continue in this way. We can do continue in this way. Clear, everybody?
Yes.
Now say this is your number 2, this is your number 3, and this is your number 4. So from 1, 2 and 4, from equation 1, 2 and 4 we get, or we can transfer this equation 3. So dy by dx that equal to dy by dr, this one, but before that I substitute the value of dr by dx because it is very simple, 1 by h. So 1 by h into whole this expression, that means delta y0 plus 1 by 2 factorial 2r minus 1 delta square y0 plus 3r square minus 6r plus 2 divided by 3 factorial delta cube y0 and so on. Yes or no? Done?
Yes.
So this is our general expression for the value of dy by dx. Okay, done?
Yes.
Now if you put x is equal to x0, then what happen? If you put x is equal to x0, then you can observe our r. So what is the value of r? So r is equal to 0 because x0 minus x0, that will be 0.
Yes.
So this formula transferred into the form dy by dx is equal to 1 by h. Substitute r is equal to 0 in each term. So we get delta y0 plus, sorry, minus, because this will be 0. So minus delta square y0 divided by 2 factorial. Then next one plus this will be 0, 0, 2. So 2 by 3 factorial delta q by 0 and continue in this way. Is it okay, everybody?
Yes, sir.
Any problem?
No.
No, sir.
Okay, this is very simple. Okay, so this is our first derivative. Okay, now I want to find our second derivative. That means d square y by dx square. So how we will get this? Anybody have the idea about chain rule? Anybody?
Excuse me, sir.
Yes.
Sir, my some internet connection was lost. That's why I was unable to understand that one. That
Okay.
how did you do that dy by dx? That x is equal to x0 r0.
Yes, at x is equal to x0. Okay, so it is very simple, Krishna. This is the general formula. Yes or no?
Yes, which we derive from that one.
That one from above expression. This one. I substitute the value of dy by dr from this equation number 4 and the value of dr by dx from equation number 2. So we will get this one. Okay.
Yes.
Now suppose I want to find the derivative value of this derivative at point x is equal to x0. Okay. So for that my r will be 0 because in our expression x minus x0, that means x0 minus x0. So this will be 0. So now substitute r is equal to 0 in above formula. So we will get dy by dx at x is equal to x0. So we have 1 by h delta y0 minus this will be 0. So minus 1. And so minus delta square y0 by 2 factorial and continue in this way. Okay, Krishna?
Okay, sir.
Okay, now I am discussing about the second derivative. So you can see the derivative, that means d by dx, and second derivative will be find out in this way, dx into dx by dr. Sorry, not in this way. Sorry, my mistake. This will be d by dr. Okay, d by dr of this one into dr by dx. This is the chain rule. Okay, dr by dx. So d by dr, d by r by dx. In same the manner of this one. Here we want to differentiate y. So dy by dr is there. Now here y is replaced by dy by dx. So this will be transferred into dy by dx. You can see. Understand?
Yes.
Okay, so now again dr by dx is my 1 by h. Okay, so this will be 1 by h into d by dr of dy by dx. Yes or no? Is it?
Yes.
Okay, so say this is our equation number 6. Okay, and I say this is our equation number 5, which is we derived. Now, what is the value of dy by dx? We already mentioned in, or we already find in the equation number 5. Now differentiate this equation again with respect to r. So what we get? So differentiate equation number 5 with respect to r. So what we get here again? So d by dr of dy by dx, that equal to 1 by h is that. So differentiation of delta y0 in terms of r, 0, because there is no r. Yes or no?
Yes.
Yes. Okay. Plus the derivative of 2r is 2 divided by 2 factorial. Derivative of 1 is 0. So this will be delta square y0 plus. Now differentiate this with respect to r. So this will be your 6r minus 6 plus 0 divided by 3 factorial into delta cube y0 and continue in this way. Understand? Justin, do you get in?
Yes, sir. Yes, sir.
Okay. Now, what about others?
Yes, sir.
Okay. So, if you simplify, then this will be 1 by h. These two will be cancelled out. So, del square y0. Here again 6 and 3 factorial will be 6. So, plus r minus 1 divided by 1. That will be 1 into delta q y0, and simply in this way you can continue. Okay, so now replace this value in our expression number 6. So we will get the second derivative. So del square y by dx square, that will be 1 by h into 1 by h. So 1 by h square, and the expression will be del square y0 plus r minus 1 del cube y0, and continue this way. Okay, done everybody?
Yes.
Okay, so any question, any doubt in this formula?
Sir,
Yes, man, yes.
sir, 1 upon x square is there.
Yes, 1 upon h square in this way. You can see 1 upon h is already there, man. 1 upon h is already there. And the difference d by dr of dy by dx is already 1 upon h. So 1 upon h into 1 upon h, and other part will be same. So 1 upon h square. Now, done, man?
Yes, sir.
Okay. So any question, any doubt in the development of d square y by dx square or dy by dx?
No, sir.
Okay, so both are our main formula. Now same formula or same concept for the Newton backward interpolation. So Newton backward interpolation formula, then we will stop. Okay, we conclude this session after deriving these formulas. Okay, so Newton backward interpolation. So Newton backward interpolation, what is the formula for that? Y is equal to, anybody? Newton backward interpolation formula. No one?
Formula is, sir, yn plus
Yes.
r,
R,
that
yes.
that
Nebula yn, very
nebula
good.
yn plus r plus 1 divided by 2 factorial nebula square yn
Okay.
plus
Then
r plus 1 r plus 2 divided by 3 factorial nebula cube yn dot dot dot.
very good. Very good. Done. Okay, yn and so on. Clear? Okay, so same formula here. So and R is that xn minus, sorry, x minus xn divided by h. Yes or no? Yeah, x minus xn.
Yes.
Okay, so x minus xn divided by h. So from that we have dr by dh. So dr by dx, x, yes, x, dr by dx, that will be again 1 by h. Agree, everybody?
Yes.
And from this first we will get dy by dr. So what will be my dy by dr? So 0 plus nebula yn plus 0 plus, okay, 0 plus nebula yn plus, if you solve this, then we will get here r square plus r. So the differentiation of that r square plus r will be 2r plus 1 divided by 2 factorial, and this will be your nebula square yn. Now next term, so if you simplify this, then you will get r square plus r into r plus 2, and it gives you r cube plus 2r square plus r plus 2r. Yes, so no, r square, yes, r square plus 2r. So this will be r cube plus 3r square plus 2r. So if you differentiate it, then we will get here 3r square plus 6r plus 2 divided by 3 factorial into delta cube y and continue in this way. Now any question?
No.
Okay, so now we will get our first derivative dy by dx is equal to, so dy by dr into dr by dx, as we already done that part. So 1 upon h, and copy this answer here. So nebula yn plus 2r plus 1 divided by 2 factorial nebula square yn plus 3r square plus 6r plus 2 divided by 3 factorial into nebula cube yn and so on. Done? Everybody understand?
Yes.
So this formula is derived from our Newton backward interpolation formula. Okay. Now again, if you substitute here x is equal to x0, then our, sorry, xn, then our r is equal to 0. So for that we will get dy by dx at x is equal to xn in form of 1 upon h, then nebula yn plus r is 0, so 1 by 2 factorial nebula square yn plus 0 0 2, so 2 by 6, sorry, 3 factorial, 2 by 3 factorial, and here we will get nebula cube yn and continue in this way. Now clear, everybody?
Yes.
Same idea is there. Okay, now we will derive for this second derivative. Okay, second derivative, that is your d square y by dx square. So again this will be nothing but d by dr, dy by dx into dr by dx. So dr by dx is h, so 1 by h is there, and d by dr of dy by dx we have to calculate. So what is the answer of this one? So you can see here, so d by dr of dy by dx will be differentiation of this highlighted formula with respect to r. So 1 by h is there, already there. This will be tends to 0. Now the differentiation of this 2r plus 1 with respect to r. So 2 plus 0. So 2 by 2 factorial nebula square yn plus differentiation of this one. So this will be your 6r plus 6 divided by 3 factorial nebula qyn and continuing this way. So if you substitute these values in above formulas, then we will get d square y by dx square is nothing but d1 by h square, because 1 upon h into 1 upon h. Then this will be 2 by 2 factorial, so nebula square yn plus this will be 6 is outside, so r plus 1 divided by 3 factorial. 3 factorial means 6, so 6 will be cancelled out, so 1 we have, nebula q yn and so on. So our final answer is 1 upon h square nebula square yn plus r plus 1 into nebula cube yn, and continuing this way you will get your final answer. Okay, so is there any doubt, any question in the derivation of d square y by dx square dy by dx with the help of Newton's backward interpolation formula? Any question?
No, sir.
Okay, so we stop here. What about others?
No, sir.
Okay, so we stop here in this today's lecture, because I know that you have to go for your lunch. Okay, so we continue with this method in the next online class. That is a simple method, okay, not a complicated method, but the derivation you have to keep in your mind. Okay, so is there any doubt, any question in today's class? Anybody?
સર આ ડેરિવેશન જે છે એ કઈ એટલું બધું આમ એક્ઝામ માટે યાદ રાખવાની જરૂર નથી ને?
No. But if you forgot during the examination, then you can derive in this way also.
Okay.
Okay, so suppose you forgot to formula. Okay, then you can write down all these steps in rough work and go with your formula directly. Done? So any question, any doubt? Anybody in today's class? I want confirmation from all the students. Please confirm yourself. What about others? Justin, Ayush?
All is good, sir.
All is
No problem.
okay. So we stop here.